Alright, the last video for this section. All the probability that we've been looking at so far is technically called theoretical probability. That means every single event had the same opportunity to occur. Now we're going to get to something called experimental probability, where you literally have to run an experiment because not every outcome has the same chance to occur. So let's say if a bag of M&Ms, the candies are colored red, green, blue, yellow, brown, yellow, and orange. Say we open a bag and counted all the colors in the table. So we have 6 red, all right, 3 green, 1 blue, 3 brown, 5 yellow, 2 orange. Count up all the M&Ms, a total of 20. And we could say, all right, seeing that we had 6 red, that's 6 out of 20 or 3 out of 10 with a probability of 0.3. Either as a fraction or a decimal. Green would be 3 out of 20.15. Blue would be 1 out of 20.05. Brown would be the same as green, 3 out of 20 or 0.15. Yellow would be 5 out of 20, which is 1/4 or 0.25. And orange would be 2 out of 20, 1/10 or 0.1. But if you add up all these probabilities, it's going to add up to be 1. So what we could say is, okay, if I get to another bag of M&Ms, what's the probability that I can pick out a red? It would probably, we would want to say, oh, our guess would be 3 out of 10 or 0.3. Now, is this enough to justify your probabilities? Absolutely not. You need lots and lots and lots of M&Ms. You need to open lots of bags to get lots of probabilities and combine this all together to find out what the probability of getting a red, green, blue, brown, yellow, or orange would be. Experimental probability is not probably the best to use if you are going to only have a very small experiment. It needs to be huge. Okay? All right, my last example here, I wanted to compare probabilities with and without replacement arrangements versus groups. All right, so our condition is a bag contains 5 red chips, 3 white chips, and 2 blue chips. Find the following probability. If they wanted to find the probability of red, white, and blue in order with replacement, if it says with replacement, you can't use permutations or combinations. What you have to do is we're going to have to find the total, which is 10 chips, and we are going to literally have to find each probability in order. Okay, so we're going to do red first. On your first pick, they want red. So 5 out of the 10. Okay, now I get to take the red chip and I get to put it back into the bag because it said replacement. So the probability of white would be 3 chips out of 10. That's my second pick. And the third pick is going to be blue. And there's 2 blue. I put the white chip back in, 2 over 10. Multiply across, do any cancellations you want. So for example, the 5 and the 2 multiply to be 10. So we can cancel that. So 3 tenths times 1/10, that's 3 over 100, or basically 3%. All right. Second probability, red, white, and blue in order again, but this time no replacement. So again, first pick, 5 out of 10, but now notice the second pick for the white. The denominator reduced by 1, just like that birthday problem we saw earlier. So that's going to be 3 out of 9 for white, then the blue will be 2 out of 8. That denominator keeps reducing by 1. Once you have your 3 probabilities, we'll multiply these together. All right, 5 and 2 again can cancel the 10. 3 can go into 9, or you go 2 and 8. But however you want to cancel, you can. So 1/2, 1/3, 1/4 multiplies together to be 1/24. All right, next. Now it's the probability of one of each color with replacement. Notice these were an arrangement. Order mattered. Now order doesn't matter. So how are we going to figure it? Do we have to do all these probabilities? Like red, white, blue, then red, blue, and white, and then maybe a white, blue, red. Do we have to do all these for every No, you don't. I'll show you how we fix this. So one of each color with replacement is basically the same probability you had up here. All right, the 3 over the 100, it's the same thing. But now that's specifically for red, white, and blue. Now, as I told you, if you thought we had to go find red, white, blue, red, blue, white, white, red, blue, white, blue, red, white, and blue, white, red, you could do that, or because there's going to be 6 of those possibilities, and there's 3 colors that you're possibly arranging here, you just say 3 factorial will give you all those different possible arrangements. So it's the first probability, and all you do is multiply it by 3 factorial, which is the 6, and that's going to increase your probability from 3 over 100 to 18 over 100. Because when order matters, probability is much, much smaller. When order doesn't matter, probability increases. Everybody got that? Good? Then, same thing down here. One of each color without replacement. That's the same as what we had here, but it was in order. Again, you take the red, white, and blue probability, 1 over 24, and you have to multiply it by that 3 factorial again, because order doesn't matter. So we multiply the 1 over 24 by 6, and we get 1/4. Okay? So that's how you could handle these probabilities. Order, not in order, which is arrangement versus groups, with replacement, without replacement. Now, 2 of these probabilities, the ones without replacement, those are special. Those are your permutations and combinations. So if you recognize without replacement, you could do these 2 probabilities a different way. All right? Remember, order is a permutation. Order doesn't matter is a combination. So we could set this up as a permutation. Your denominator, there's 10 total chips, and you want to pick out 3 chips. 1, 2, 3. So the denominator is 10 permutation 3. On the top, because order matters, it's a permutation. There's 5 red chips, you want 1, so that's 5 permutation 1, times 3 white chips, you want 1 of them, 3 permutation 1. There's 2 blue chips, so 2 permutation 1. Multiply those all together, put it over this number, and that's going to be your probability. But the one thing I want you to notice is, if you will know if you've got this set up right, notice all the n numbers on the top, the 5, the 3, and the 2, they have to add up to be that 10. The R values, 1 plus 1 plus 1, has to add up to be that 3, the R value on the bottom. All right, so now let's say you wanted to pick 6 chips. All right, 6 chips, and you wanted them in order red, red, white, white, blue, blue. Then 10 permutation 6, all the ones becomes 2s. Or you wanted 3 red, 2 white, 1 blue. 5 permutation 3, 3 permutation 2, 2 permutation 1. Okay? And when you have order doesn't matter, this becomes a grouping. And again, I'm showing you how to type it into the calculator, but we've already done permutation, so you'll still get the same thing. Combination, it's the same concept, but now instead of all permutation p's, we put in all combinations. 10 combination 3 on the bottom, 5 combination 1 times 3 combination 1 times 2 combination 1. And again, here's the best part. It doesn't matter what order these permutations come on the top. Or I should say combinations. Same's true up here. Doesn't matter. All right, but what does matter is that all the n's have to add up to be 10, all the ones have to add up to be 3. Now, for example, you could add for either one. You could say, oh, what's going to be, and I've seen people do this, I want to have 2 red and 1 white. 5 combination 2, 3 combination 1, 2 combination 0. You can put a 0 there. It will still get you the same answer. All right? So again, crunch this into the calculator the same fashion. Multiply all your combinations together. Divide by your 10 combination 3. And I always like, at the older calculators, you got to tell it to return it as a fraction. Whereas with the new calculators, again, because you have the fraction feature, you can go alpha y equals fraction, and we can go 5 math probability number 2. Whoops. Well, we'll do the first one then. With a 1, get out of that. That's the key here, is you got to watch the new calculator, that arrow. You don't want to hit the times symbol here because you'll put it down at the subscript. Right arrow out, times. Then we want to do 3 permutation. 3 math over to probability number 2 for permutation 1. Right arrow out of there, times 2 math probability number 2, put in your 1, and then 10 math probability permutation number 2, 3, and now you hit enter. It'll leave it in fractional form for you. All right, so that's the last of our probabilities.